Let's talk a little bit about the following, quadratics. So the quadratic function is simple as it could possibly be. Is an x that you have that's squared. That's going to give us our nice simple quadratic. Quadratics, of course, gives us a nice little parabola. So the whole idea is we want to learn about completing the square and when and why and how we use it. So let's dig in deeper to quadratics and talk about them. So if you want to really understand how functions work, quadratic, exponential, linear, doesn't matter. You got to know how the graphs work, okay? Because this function is going to relate to something on this graph. So here's a basic way I work with graphs, which is just making a little function table here and plugging some numbers in. So my x's are my inputs, and I'm going to plug them in here into my equation for x. So for -2, I'm plugging in here for x, right? So that'll give me -2 squared, -1 squared, 0 squared, 1 squared, and 2 squared. So the reason I'm doing this is to give me 1, 2, 3, 4, 5 points that I can graph and hopefully see what this function actually looks like, okay? So if I do my -2, plug it in for x, -2 squared is 4, -1 squared is 1, 0 squared is always 0, 1 squared is 1, and 2 squared
Mr. Foster, please dial the front office. Mr. Foster, please dial the front office.
Alright, but if we're looking right here, we have our actual kind of nice little symmetry here. You see we have 4, 1, 0, 1, 4. So that symmetry is what's going to give us our parabola. So what we're going to do now is we're going to plot these points. So we're going to plot the point -2, 4. Looks something like this. This might be something you're more familiar with the x squared and the x, okay? Now again, if you want to see what this thing really looks like, you can always just plug numbers in and graph it. So let's try that. Let's just try plugging some numbers in. So I'm going to use these same numbers here and see what happens. And on down here. All I've done is I plugged in all of these x's for both of these x's in here. And I'm simply going to do the math. Alright, so let's try graphing some of these points I have. And that's somewhere up here. And of course the other one's somewhere up here. Point is, I got another fancy little quadratic, as you can see. When we have our original x squared function, the vertex is right here at the origin. For this one, it's now moved, okay? So that's what we want to talk about how it moves, where it moves, why it moves, okay? So, for that, let's come over here to this. The question is, what can we learn about this quadratic? Okay, so let's think here. When I'm graphing a quadratic, there are a couple things I can look at. Number one, I can look at this small point down here, which is called the vertex. And knowing the vertex is important because it knows either the bottom part of my graph or it tells me the top part of my graph. Either way, they're both the vertex. So knowing the vertex is important. And we'll talk about how to change that standard form quadratic there into vertex form. We can also create what we call zeros, right? And so that's intercept form. When we say intercept form and zeros, what we're talking about is where it crosses the x-axis. So that's what intercept form is. Intercept form would look something like this. Okay? So this is where we have our two factors here, all right, of a quadratic, and then we set it equal to 0. Because in this case, everything on here, every x value, is where the y is equal to 0. So that's one way to write it. We can also write it in vertex form. Now, one thing I will say is this. If you look at this function right here, this equation right here, okay? X squared plus 2x plus 2. We can complete the square and find a vertex easily, all right? Where we simply do something like x plus 1 squared plus 1. But the point is, once I get my vertex form here, all right, I can calculate the vertex pretty easily. However, can we find the intercept form of this? Or what are the zeros? Well, if you'll notice, does my quadratic cross the x-axis anywhere? And the answer is no. And so if I try to do some kind of breaking down intercept form, x, what number multiplies to 2 and adds to 2? Odds are you probably can't think of one. And that's because there are no zeros. there are no intercepts here, okay? So the reason I'm bringing all that up is when I come over here to this guy, I can find two things. I can find its intercepts, so in other words, it's x-intercepts, that's where the y equals 0, right? And I can also find its vertex, and for that I need vertex form. Okay, so we gotta be able to do both. So let's start by doing both here. So we'll start with the x-intercepts here, all right? So, I don't know why that's had such a difficult time. There you go. All right, so if we take our x squared plus 6x plus 8, let's try to find its x-intercepts, all right, where y is 0. So I'll start by factoring these. So what I need is a number, or numbers, two numbers, that multiply to 8 and add to 6. I'll give you some time to think. What two numbers would work? Multiplying to 8 and adding to 6. 4 and 2. Okay? So, these are my two factors of this. This is what we call intercept form. It's the same function, just rewritten as intercepts, the x-intercepts, okay? And so if I want to find out what the actual x values are, I set it equal to 0. But these are my factors of the original quadratic. And when I have my factors, I can set each of them up equal to 0. Alright, and once I have them up equal to 0, you solve. X equals -4, x equals -2. So in other words, I know if I graph this function right here, it is going to cross the x-axis at -4 and -2. Guaranteed. Alright, that's what my x-intercept form is about, the intercept form. Alright, where y equals 0, where it crosses the x-axis. Okay? Now if I come over here to vertex form, the vertex form is going to require a little bit more work. So let's give ourselves a little bit more room here. Alright? And focus on this. So for vertex form, I'm going to take my original function, x squared plus 6x plus 8. And I want to find, in this case, what the bottommost point is, the vertex. So, the vertex form, the method we use is called completing the square. So what I'm going to try to do is change this function into a perfect square function. Now, for those of you who know, when we have x squared plus 6x, the perfect square of this wouldn't be a plus 8, it would be a plus 9. What number multiplied by itself gives me 9 and adds to 6? Well, that should be pretty obvious because it's 3. 3 times 3 is 9. 3 plus 3 is 6. So that's the number. And it's the same for both. Both are a positive 3. So in this case, what I get is 2 positive 3's, right? That's important. This is x plus 3 squared. So when I'm talking about completing the square, what I'm trying to do is I'm trying to find a perfect square quadratic that gives me these perfect square factors. Okay? So I'm going to look at this again and I'll see that this is, again, it's not quite a perfect square. It's got 8 instead of 9. So what I'm going to do is I'm going to kick that 8 out the way by isolating my x's. Okay? And I'm going to plug in the number that I want. What number do I want? I want 9 there. So I'll plug in a 9. Unfortunately, if I do plug a 9 in here, alright, it changes the overall value of my function. I just can't add a 9 without throwing everything off. So what I have to do to balance that is, if I add a 9 in here, anywhere, alright, I have to subtract 9 somewhere else on there to keep it balanced. Okay? Now, once I get this, then all I need to do is figure out again what this b here is, what half of b is. If we have this right here, I know that the number that multiplies to 9 and adds to 6, the two numbers are 3 and 3, which just happen to be half of our b, our 6. And so those would be my two factors. And then I will combine them into one and just say x plus 3 squared. And then over here we have 8 minus 9, so that will give me a -1. So that will be my vertex. So if I graph this, I would find the following. I would find this, I would find that my vertex, we say this is -hk. In other words, you take the x, it's negative, and then the y is what it normally is. So if we're looking at this with -hk, alright, I took my 3 is positive, alright, that's my h, alright, so what I'm going to do is I'm going to change the sign. So if it's a positive here, my vertex is a negative x value, alright, and over here, That's the k. That's already negative, so it stays the same because you don't affect that value. So that gives me my vertex. You do the opposite of what's in here, and you keep what's out there. That will give me my vertex. So I get -3, -1 for my vertex, and then what are the places it crosses the x-axis? It crosses at -4 and -2. So if I were to come back over here to this, I know that my x-intercepts are -4, -2, my vertex is -3, -1. So look, I can come over here and I can plot that, -3, -1, and then I got -4 on the x and 2. And look, there's my quadratic with my vertex and my 2 x-intercepts, and that's pretty much what it's going to look like. So that's why we complete the square. We complete the square to get this fancy vertex. We find intercept form to find the zeros. And it's all through your basic factoring, all right? And over here, using what you know about perfect square quadratics, where you have the same value here, all right? The same binomial here, all right? X plus 3 and x plus 3. And again, I had to manipulate it. I had to bring in this 9 that wasn't there originally, because I didn't like the 8. So I separated, brought in the 9, and then subtracted 9 to balance things out. And then you just follow through the math. Anyways, I hope that helps. Please look through, let me know if it doesn't, okay?